If you're a business owner with a physical location that consumes a ton of energy and you want to dramatically cut your operating costs, this is for you. Exact Solar has worked with several companies and helped them do this, and it is something that a lot of business owners don't even realize they're being charged for. This works for manufacturing centers, data centers, hotels and resorts, refrigeration warehouses, concert venues, restaurants and commercial kitchens, EV charging and fleet depots, other warehouses and distribution centers, machine or metal fabrication shops, plastic or injection molding, commercial industries and laundromats, indoor farms, greenhouses, grow facilities, bakeries, foundries, metal casting centers, gyms and fitness centers, food and beverage processors. Anyone who uses a lot of heat or a lot of cooling is probably being charged more than they need to for energy for a very specific reason we'll go into in this video. And solar plus batteries can help you directly. So if you own or manage a business that has high energy costs, you should pull out your latest electric bill, and somewhere on that bill will be a line that says demand capacity or maximum demand. That one line can be 30 to 70% of your entire electric bill, and it doesn't need to be because it has nothing to do with how much energy you used. It's about how fast you used power at one single moment in the entire month. And it will probably look something like this. Demand charges are one of the most expensive and confusing parts of any business's electric bill, but thankfully, they are also one of the easiest to control. Today's video will explain what demand charges are, how your utility company calculates them, and how solar and batteries can help bring them down. So let's get into it. What is a demand charge? To understand a demand charge, you need to understand the difference between power and energy. Power is the amount of electricity that you use at any given instant, and it's measured in watts. Energy is the amount of power you use over time, because power times time equals energy. It's measured in watt hours. So again, power is measured in watts and is the amount of electricity you're using in any given instant. Energy is the amount of electricity that you use over time, and energy is power times time. So energy is measured in watt hours, power is measured in watts. A demand charge is a fee based on the fastest rate your building pulled power at your highest usage instant during a billing period for a utility, not the total energy you used over a period of time. So here's the difference in simple terms. An energy charge is the total energy you used over the month, which is measured in watt hours. A demand charge is your single highest moment of power usage in 1 month, which is measured in watts. Instead of using electricity, we can imagine water flowing through a hose to explain this concept. The energy charge bills you for the total number of gallons that flow through your hose over the month. The demand charge bills you for the moment during the month when you needed to force the most water through the hose. Imagine it like a moment when you're watering your lawn and you turned all your sprinklers on at once and ran all the water in your house and had a shower. That's basically what a demand charge is. The utility company charges you your demand charge for keeping enough water on hand so that you can get the water pressure you need at that busiest moment, even if the rest of the month is quiet. We can use a water analogy to explain demand charges, but power is very unlike water. Power has to be made and delivered the second that you need it. It can't sit around stored like water, although we are getting better at utility scale storage, but the grid isn't quite there yet. Most of the power that you use was generated the instant you used it. So to make sure power is ready even on the hottest afternoons when everyone's going to go home and turn on their AC all at once, utilities build a lot of equipment. They build power plants, they build power lines, and they build substations and transformers. And much of that sits unused for most of the year, most of the time, waiting for a few hours a year when everyone runs their air conditioning and machines at once. But because they have to pay for that infrastructure to sit there, they charge people demand charges to make sure that when you need a huge amount of power at once, they will have the capacity to deliver it to you. A business with a sharp, sudden spike in electricity puts more strain on the grid than one that uses the same power in a smooth, steady line. So let's say, you're just running a refrigerator, it's just going to look like this. But if you are running a bunch of air conditioning units and you turn them on all at once, there's going to be a massive spike in power followed by a steady operating line. And the utility is charging you for that spike in power. That's what a demand charge is. The utility figures out your demand charge by recording your demand in short blocks of time, usually every 15 minutes, all month long. At the end of the month, the utility finds your single highest usage block, which is your peak, and that's what you're billed for in a demand charge. Because it is a 15-minute average, a spike that lasts just a few seconds may not set your peak, but let's say you turn on a bunch of machines at once. If you run a manufacturing plant and at a certain point during the day, you turn on all of your machines that make widgets. There's a big spike in power. The utility is going to charge you for the spike, not for the cost to operate, because it's not a steady line. You're using a bunch of electricity at once. Here's what that peak looks like. The easiest way to see how this works is to compare two fictional businesses that use the exact same energy but in very different ways. Company one is a concert venue. They use 60,000 kilowatt hours for the entire month. Again, kilowatt hours are energy, and energy is power times time. Now, because the concert venue runs lights, sound, and projectors all at once during shows, they drive their peak up to 300 kilowatts in one 15-minute block, or for however many hours the concert was going. They have a very low energy operating cost for most of the time, and then when they're running concerts, bam, it spikes. That means their demand charge is going to be 300 kilowatts times $10 a kilowatt. That would be $3,000. But their energy charge would be 60,000 kilowatts times 12 cents per kilowatt hour, and that would be $7,200. So the total bill that the concert venue is going to have would be $10,200. Now let's compare that to Company 2, a completely different business. They're a cold storage warehouse. They also use 60,000 kilowatt hours, but their coolers run at a slow, steady rate all day, and they're not powering on a bunch of them all at once. So that means that their load is spread out, so their peak is only going to go up to 100 kilowatts. Their demand charge will be 100 kilowatts times $10 per kilowatt, which will be $1,000. So the concert venue is paying $3,000, the refrigeration warehouse is paying $1,000, but they use the same amount of energy over the course of the month. It's just that at some point during the month, the concert venue spiked their power, whereas the refrigeration warehouse had a much more flat usage graph. Over the course of a decade, so the difference would be, let's say the concert venue is 60,000 kilowatt hours a month. The refrigeration warehouse also 60,000 kilowatt hours per month. But because the concert venue has a much higher peak, they have to pay $2,000 more than the refrigeration warehouse, which has a much flatter usage curve. So over the course of a month, the concert venue is paying $2,000 more. Over the course of a year, the concert venue would be paying $24,000 more. And then over the course of a decade, the concert venue would be paying close to $250,000 to use the same energy that the refrigeration warehouse is using, but just because they need more of it at a specific time, they're paying a huge premium. And this is where things get very exciting. Because with solar and batteries, you can do what's called peak shaving, where if you're a company that has high energy use and you need to use a bunch of energy at one time, like a concert venue or a smelting facility, a metal fabrication workshop, a welding shop, anything that's spiking a lot of power all at once, you can draw from a battery to just chop the top of that peak off, and that will save you a ton of money. A well-programmed commercial scale battery can flatten the curve so that your power doesn't spike. The second demand starts to climb towards a new peak, your building can draw from a battery instead of the grid. And then when this is set up right, your electric meter never sees the spike. Here's a simple example. Say your building peaks at 250 kilowatts and you want to hold it down to 180 kilowatts. The battery must supply 70 kilowatts of power. If your peak lasts about 2 hours, the battery needs about 70 kilowatts for 2 hours, which would be 140 kilowatt hours of usable storage to cover the whole window. If the battery's too small, then on either side of the peak, it's going to run out of electricity and it's going to spike anyway. The grid will see the spike and you'll pay for the month anyway. Getting that size right is the difference between a system that works and one that you paid for that barely helps, and it's why you want to work with a reliable installer like Exact Solar, because you will never have to do these calculations on your own. You want to work with someone like us who have done this a million times and are going to size this right so that you can just chop the top off that peak and pay dramatically less for energy over the month because you're never spiking your power. You're drawing from a battery instead. Solar panels are also great at lowering the total power you buy, but cutting demand charges is something that only batteries can do. Solar by itself is a wonderful tool, but not a reliable tool for cutting demand charges. Solar panels will reduce energy usage over the course of the month. Sorry, they won't reduce energy usage. Solar panels will reduce energy charges over the course of the month, but you can't reliably time solar panels to reduce demand charges, simply because a solar energy system is only generating its full output in direct sunlight. So it ramps up in the morning, peaks at midday, and fades in late afternoon. Your demand charge is set by your single highest moment of electricity usage in the month. You cannot control the weather, so you cannot guarantee that your peak power usage will line up with direct sunlight. Some buildings peak during the day, like schools and offices. Solar can shave their peaks well. Other buildings peak in the evening, like hotels, restaurants, and shops, and solar can lower their total power use a lot, but may barely touch their demand charges because their power use is spiking in the evening and the intensity of sunlight is going down. So solar by itself is not going to lop off that peak. Solar combined with batteries are the answer to this problem. Solar and batteries each have a weak spot that the other covers. Solar makes cheap, clean power, but cannot be counted on at the exact moment of your peak. A battery can be counted on at that moment, but needs to be charged from somewhere. So when you put them together, you get the best of both. The solar makes power all day while the sun shines. Your building uses the solar energy it needs, and extra solar energy charges the battery. When your peak hits at midday or after dark, the battery sends out power to chop it off. And then on a cloudy afternoon, when solar energy is weak, the battery saves you. Businesses that invest in solar with storage can save hundreds of thousands or even millions of dollars over time. And we've saved businesses tens of millions of dollars by using this method. Again, you have cheap solar power coming in, so that reduces the energy charges that a business is experiencing. And then you have a battery that the building can pull from when energy is spiking, and it just chops the top off that peak so that the demand charge is dramatically reduced on the business owner's bill. There are also tax incentives that make batteries more compelling, and this is where the numbers often surprise business owners because many believe that with the One Big Beautiful Bill, tax incentives went away. It's not true. Tax incentives still exist for commercial batteries, and the investment tax credit will cover 30% of that system cost for projects that meet labor rules. Again, not something you need to figure out. If you work with us at Exact Solar, we will figure all that out for you. The credit applies to batteries even on their own, not just batteries paired with solar. And that's different from the home market where the battery credit for homeowners ended after 2025. Commercial buildings can still get the tax credit for batteries. There's also depreciation. Businesses can also write off the cost of the equipment, and there's a 5-year depreciation schedule called MACRS, which means you can deduct a large share of the cost up front. And there's also the energy community bonus, which is specific to Exact Solar. Most of Exact Solar's installation area has been designated as an energy community as of 2026, which means that many businesses who invest in commercial scale energy storage can qualify for an extra 10% tax credit on their project. So combined with the ITC, which is 30%, and the 10% bonus tax credit if your project falls within an energy community, which most of Exact Solar's service area does, You'd be getting 40% of the cost of this project covered upfront, and you'd be able to depreciate it almost down to nothing very quickly. So you'd be cutting your energy operating expenses at a dramatic discount, and we have seen these systems pay for themselves within 3 to 7 years, just depending on what the numbers look like for your building. For a long time, demand charges were just a fixed cost of doing business that owners had no control over. Now they're one of the most controllable parts of your bill. If you work with a reliable local installer to design and invest in a commercial scale solar plus battery system, you can dramatically lower your operating costs for decades to come. Exact Solar has designed and installed clean energy systems across Pennsylvania and New Jersey since 2005. We use our own in-house team, never subcontractors. We'd love to review your business's bills and give you our honest assessment of whether solar and storage make sense for you. Schedule your free consultation today. You can go to exactsolar.com. You can find our commercial page there to see all of the great work we've done with other companies. And we look forward to speaking with you. Thank you for tuning in today. And if you have any questions, our team would love to answer them. Again, just schedule your free consultation, drop the name of your business, and we will get back to you as soon as we can.